Okay, so today we're going to start the unit on rational expressions. And first, we're going to be looking at the properties of rational expressions. So, rational expressions have a over b form, where b, which is the denominator of this expression, is not, it cannot be equal to 0. Because if the denominator of any fraction is equal to 0, the fraction would be a undefined expression, right? And rational functions or rational expressions have a form of a fraction, something divided by something else. So we can say the rational expressions are quotients of a function divided by another. In other words, y is equal to f of x over g of x, two functions of x, right? Where the denominator, that's g of x, cannot be equal to 0. Fair enough? Okay. Now we're going to sort of start looking at undefined values. So suppose that I have our function, our rational expression as 5 over x. The value of x that would make this expression undefined is when we have x equal to 0, right? It makes it division by 0, which is not defined in mathematics. So we go, okay, the undefined value is when 5 divided by 0, right? So x equal to 0 would make this expression undefined. So we go, okay, x cannot be equal to 0. So we put equality and put a slash through it. We go, okay, x cannot be equal to 0 because x is non-permissible. X is a non-permissible value. Sorry, a 0 is a non-permissible value for x, right? So x cannot be equal to 0. Okay. Now, the next expression that we have is 7x over x minus 2. Okay. What would make this expression undefined? Okay. If x minus 2 was equal to 0, then this expression would be undefined because it would become a division by 0, right? So we go, okay, this cannot happen, so I'm going to put a slash through that, and I'm going to solve it just like any basic equation that we've done. We go, okay, add 2 to both sides, right? Then we go, okay, x cannot be equal to positive 2. That's a non-permissible value. Because if x is equal to 2, then the denominator of this equation becomes 0. The denominator of this expression becomes 0, and if the denominator of a fraction is equal to 0, then the fraction is undefined. So we cannot have x equal to 2. We go to the next one. We have 8 divided by x squared minus 6x plus 8, right? Okay, right away we can't see what the non-permissible values are, but we know that x squared minus 6x plus 8 would make this expression undefined, right? If this is equal to 0, it would be undefined. So x squared minus 6x plus 8 equal to 0 would make this undefined. We go, okay, then the denominator cannot be equal to 0. I put a slash through it. We go, okay, but I don't know what values of x, so I'm going to factor this. I go, okay, if I factor this expression, I get two numbers that multiply to make positive 8 and add up to make negative 6. So it would be negative 2 and negative 4. This product cannot be equal to 0. I'll solve it just like any basic equation. I go, okay, the first one cannot be equal to 0, so x minus 2 cannot be equal to 0. And the second one cannot be equal to 0. I'm going to get some more space. Second one, x minus 4 cannot be equal to 0. From the first one, I conclude that x cannot be equal to 2. And from the second one, I conclude that x cannot be equal to 4. Because those two values will make the denominator of this expression 0, And if the denominator is equal to 0, then the whole expression is undefined. Right? So these are the non-permissible values. X cannot be equal to 2 and x cannot be equal to 4. So this process is called finding the non-permissible values of x or the variable. Right? Those are like finding the non-permissible values. So we're going to do one more example of this, and then we're going to go after a couple other things. Okay, we want to find the non-permissible values of x in this particular expression, which has x minus 6 over x squared minus 36. Okay, in the form that it is, I'm going to say x squared minus 36 cannot be equal to 0. I do not change anything, right? With the form that I've been given, I go, okay, the denominator of this fraction or this rational expression cannot be equal to 0. I'm going to factor it. Go, okay, this is an x minus 6 times x plus 6 because it is a difference of squares. This cannot be equal to 0. Each factor, therefore, cannot be equal to 0. I'm going to solve it just like any old equation. So x minus 6 cannot be equal to 0 and x plus 6 cannot be equal to 0. From each one, I will conclude that x cannot be equal to 6 and x cannot be equal to negative 6. So I went with the expression of x that I had in the denominator without any modification, right? Without any modification, I put the denominator and say, okay, that cannot be equal to 0. A common error is that you go x minus 6 on top, you factor it first, cancel out the x minus 6, and then state that x plus 6 cannot be equal to 0 and x cannot be equal to negative 6. That's a common error, not finding the other non-permissible. So this is halfway, right? This is halfway. You're removing the factor before you're finding the non-permissibles. So find the non-permissibles first, right? Then after you found the non-permissibles, then you go after simplifying the rational expression, which is our next topic. Okay, simplifying rational expressions is something that we're going to do. There are 3 steps involved in this. First step, we factor the numerator and the denominator. Second step, you state the non-permissible values, right? Or basically find out what makes the denominator 0, right? And then cancel the common factors from the numerator and the denominator. So, like first, you state the non-permissibles, then do some cancellations to simplify. Okay? So now we're going to use this 3-step process to simplify some rational expressions. I have 2x plus 10 over 6x plus 30. Step 1, we want to factor the numerator and the denominator. We take the GCF of the top, 2 times x plus 5 over, I take 6 as a factor at the bottom, 6 times x plus 5. Step 2 says state the non-permissible values. So what we're going to do, we're going to set the denominator equal to 0. Okay, if this was equal to 0, it would make the expression undefined, right? So okay, this cannot be equal to 0. We know 6 is never equal to 0, so we don't have to worry about that. Okay, then x plus 5 cannot be equal to 0. If we solve this for 5, we go, okay, x cannot be equal to negative 5. That's the non-permissible value of x. And then in a couple of lessons, we'll find out what that means. Why, like we say that. It's kind of like the like what we had with radical equations. There are some values that are allowed and some values that are not allowed, right? This is a non-permissible value for x. This is a value that's not allowed for x to happen with this particular expression. So now that we found the non-permissible value, we go, okay, simplify, that's the last step, or cancel out the common factors between the numerator and the denominator. Okay. The x plus 5 is a factor of the top, right? It is a factor of the top. I can cancel it out with something in the denominator, right? 2 over 6. I have 2 over 6 left over. And you go, okay, this is 2 over 2 times 3. Now I have a common factor. Common factor, meaning multiplication in the top and the bottom. So I have 1/3. So the simplified version of that expression is 1 over 3, but there is a non-permissible value, and x cannot be equal to -5. Next, I'm going to do the same thing with this one. First, I'm going to factor the numerator and the denominator. Okay, there's a common factor between the two terms in the numerator. So I take a 4 as a common factor out. This becomes x plus 2. And then the denominator, I'm going to write it in the reverse order. I can do that with addition. I can change the order. And I go, okay, what is the non-permissible value, the second step? Okay, x plus 2 cannot be equal to 0. I solve it like any old equation. This tells me that x cannot be equal to -2. That's the non-permissible value. Once I found the non-permissible value, I simplify the expression. The common factor between numerator and the denominator is x plus 2. Cancels out, then I get 4 over 1, which is equal to 4. So it's simplified, but there is a non-permissible value at -2. Okay? You're going to do something slightly different with this one. Okay, we want to simplify this. I'm going to do the same steps. I take the common factor out of the top. I get x minus 2. So 4 is the GCF of the top. I take it out and I have x minus 2 left over. Then I have 2 minus x at the bottom. You go, okay, we want to state the non-permissible values. You go, okay, 2 minus x cannot be equal to 0. Solve it with any equation, or just like any old equation. Then you get x cannot be equal to +2. That's the non-permissible value. We've stated it. Now we can go after simplifying this. Okay, this is 4 times x minus 2 over 2 minus x. And notice something, that these two, right, that we have inside the brackets, x minus 2 and 2 minus x, look very similar, right? One is x minus 2, the other one is 2 minus x. They have the same elements, right? The order is reversed, right? Okay, the top, okay, I'll keep the top the same, x minus 2. But what can I do to the bottom to make it look like the top so we can cancel it out? Or factor out a -1. I can factor out a -1, and if I factor out a -1, I can change it into minus 2 plus x. So I haven't really changed anything here, right? Because if I multiply that negative through, it'll be the same thing as it was before. I haven't changed it. I just changed the form of it, right? So you go, okay, 4 times x minus 2 is left on top. The bottom is changed to the form minus brackets x minus 2, right? Now you go, okay, x minus 2 is common between the numerator and the denominator, so I can cancel it out. So this becomes 4 divided by -1, which is equal to -4. Fair enough? So factoring it out is something that gave me a way out. Now, we want to simplify and state the non-permissible values of this rational expression that we have. It's 8 over x squared minus 6x plus 8. Okay, we need to factor the numerator and the denominator. The numerator, I can't really do anything to it, right? But can we factor the denominator? What two numbers multiply to make 8 and add up to -6? -2 and -4, right? So we have it in factored form. Part 2 says that, okay, what values of x, or find the, what values of x would make the denominator equal to 0, or find the non-permissible values of x. Okay, x minus 2 times x minus 4 equal to 0 would make the denominator 0, and it would make the rational expression undefined. So they cannot be equal to 0. We will do the same as what we would do with any equation. We set each one not equal to 0. So x minus 2 cannot be equal to 0, and x minus 4 cannot be equal to 0. From the first one, we can conclude that x cannot be equal to 2. From the second one, we can conclude that x cannot be equal to 4. Okay, these are the two non-permissible values of x. So we've stated the non-permissible values, right? Now, we want to simplify this expression. So we take the 8 over x squared minus 6x plus 8. You go, okay, can this be simplified any further? No, it can't be, because there's no common factor between the numerator and the denominator, so we can just leave it as it is, right? But we can leave it in a factored form. So those are the things that we're going to be looking at: simplifying rational expressions and finding the values that the variable cannot accept, right? Now, I'm just going to give you guys some heads up, and there's also like some of them in your workbook. Some heads up about some common errors that you would get when you're simplifying radicals, or some common errors that you should be looking out for, or be careful with. So sometimes you see that like there are some common elements in the numerator and in the denominator. You have x squared plus 6x minus 3, and the denominator is x squared minus 3. It's very common to see that people write it as x squared minus 3 plus 6x, write it in a bit of distance, and then x squared minus 3, and then cancel this out. This is an error. Why is this an error? Because they're not factors. This is added here. These are separated by plus and minus. So if they're separated by plus and minus, they're not factors. They cannot be canceled out, right? So this is a common error. It's and we see it all the time. Another common error: you see something that's common in top and the bottom as one term, right? A lot of people just cancel the x's and write it as 3 over -2. Very common. What is wrong with that? Same thing, right? These are these terms are added to each other. They're separated by plus and minus. These are separate terms. They're not factors, right? So notice that I keep repeating that they're not factors, right? Another common error. People see something like this, 2x squared minus 9 over 2x minus 3. They cancel the 2's because they're at the beginning, right? Rewrite it as x squared minus 9 over x minus 3. And then factor x minus 3, x plus 3, or factor the top into those two. And then the x minus 3 from the top and the bottom cancel each other out. And this is simplified. What is wrong with this simplification? What is wrong with this? Where did the error start? At the beginning, we cannot cancel this 2 because it's not a factor. That 2 has to be a factor of both terms on the top and both terms at the bottom. Right? So it has to be factored. Another common error, right? Again, people see a common term. This is a very, very easy thing for people to sort of like follow and make mistakes on. Canceling out something that is common between the top and the bottom, but not a common factor, right? So let's make a rule, okay, to cancel a term out. It has to be a common factor get some more space. It has to be a common factor. I'm going to write that in capitals. A common factor of the top and the bottom. Fair enough? So it has to be a common factor of the top and the bottom. If it's not a common factor, then you cannot cancel it out. Fair enough? There are some H work that you guys need to do. And the H work is on page 52, 2.1. Make sure that you are getting to the more conceptual, the higher level sort of questions, because that's where the chickens are counted. Yeah? Well, Summer knows what I'm talking about.